Welcome. We are the Team Trackmania Challengers, and we would like to share with you our journey in creating an AI agent for the game Trackmania. Trackmania is a video game with a unique take on the car racing genre. In this game, the player's performance is gauged according to the time taken by them to complete a track. Thus, the objective of this game is to complete tracks filled with various obstacles, ramps, barrels, and turns in record time. Unlike other racing games, the Trackmania series lets the player race a track as many times as they want within a time limit. Players may choose to respawn at any time if they land upside down, leave the track, or get off to a poor start, which makes it a great environment to train a reinforcement learning agent. The objective of this project was to develop an agent capable of completing a baseline track, which offered a sufficient challenge for the AI agent to complete. We started by exploring several methods of solving this particular problem. The most promising of these methods was developing a DQN agent to complete the race. In order to get a feedback of the action performed by the agent in our environment, we implemented three neural networks. The first model detected the speed of the car, the second detected the time since the race started, and the third model was used to detect collisions of the car with either the obstacles or boundaries of the track itself. These were used to calculate the reward or penalty given in terms of feedback to our agent to optimize its Q values. We experimented with several reward functions and CNN models of our DQN agent. We began the training process with a simple straight track. The agent was trained on this track and it gradually started to perform well. Finally, it managed to complete the straight track in optimum time. The agent was now ready to face a better challenge, a track with few turns. During the learning process, we observed that the car was completing the race, however, it had just learned to go forward. This is the reason why our agent completed this new track by bouncing on the edges of the track. We thus changed the way in which we dealt with states. A stack of 6 frames was reduced to a queue of 6 frames. We then changed the structure of our network. Max pooling layers are known to disturb the spatial features in images as they downsample the input. These layers were removed. We found that they are good for classification but not great for our game. We also increased the stride of our convolutions, which saved time required to fit the model at every stage. The number of learnable parameters in the network was reduced from 20 million to 1 million. The loss function was changed from MSE to Huber as it doesn't punish the model as hard as MSE does whenever any outlier is encountered. The agent was then trained for 6,000 episodes and completed the race in 7.78 seconds, which is a significant progress, as a human can complete this race in a record time of 7 seconds. Following were the results of a modified agent. Each run consisted of 2,000 episodes, and the weights from the nth run were used for n+1th run. During the course of this project, we did run into several obstacles. Training on the local machine was quite slow. Hyperparameter tuning was difficult as training itself took several hours for any intuitive insight into its quality. Problems with gradient explosion were solved by clipping the gradient. Gauging the parameters to be included in the reward function was also a big challenge. There is a vast scope for future work in this area, which includes perfecting the agent to complete more advanced versions of the tracks found in this game. Adding a parameter which helps in defining the sense of correct direction in the reward function will also help the agent to learn a track faster. These are a few references which helped us tremendously throughout our entire project. Thank you and have a good day.